Hey guys, I wanted to work some examples that are in your notes with you before you try some practice on your own. I've copied and pasted the steps that are in your notes on to this OneNote document and as well as those practice problems, and I'm going to work those examples for you, and then you have some additional practice problems you can work on your own. It's probably helpful for you to have a periodic table handy. I have a mug that I use from time to time, like a cool periodic table mug, but I also remember a lot of these elements just because I've done this a lot of times. So yeah, it might be helpful to just have your periodic table that you got in your lab kit handy. Okay, I'm going to start with CS2, that's carbon disulfide. And the first thing I need to do is count up the total number of valence electrons. And I remember I figure out how many valence electrons an atom has by looking at its group in the periodic table. And I know that carbon has 4, it's in group 4. And sulfur is in group 6, and there are 2 of them, so there's 6. So I'm going to have 4, that's an arrow, plus 6 electrons times 2 atoms. So that's a total of 16 electrons. Okay, so I need to be placing 16 electrons total around these 2 atoms. Now, I know that carbon has 4 and each sulfur has 6, but that doesn't mean that in the final structure it's going to have only 4 and have only 6. Remember, covalent bonding means that elements are sharing electrons to form a total of 8. In the case of most elements, or sometimes there's some octet violators we'll talk about later, but we know for sure hydrogen only gets 2 total, ever. Okay, so now the next step number 2, is to draw this, what's called a stick structure. And this is sort of like the basic way that these atoms are arranged, not taking into account the shape of of the molecule. Okay, so I can see that there's 1 carbon and 2 sulfurs, and typically that means that their carbon is going to be in the middle of the 2 sulfurs. And since carbon is sort of like got 4, it's pretty much always in the middle. All right, so I just did like that, and I'm going to arrange them in a horizontal line. All right, now what I need to do is I'm going to draw a single covalent bond connecting these 2, and that'll be the first set of electrons that I use of my 16. So I'm just going to draw 2 bonds like that. And remember, each of those single lines counts as 2 electrons. So now I've used up 4. I'm going to subtract 4, and now I have 12 electrons that I need to place. And I'm gonna just place those electrons around the outside sulfurs. All right, so there's my 12. Okay, so now I'm done. So now what I need to do is check to make sure that every element has an octet of electrons, okay? So sulfur, I'm gonna look at both sulfurs and I can see that they're the same. So I'm only gonna check really 1 sulfur, and if that one's okay, then they're both okay. So I've got 2 electrons, 4, 6, and then this bond is 8. Right? So even every lone pair is 2, and every single bond is 2. So this one has 8, and so that one has 8. And then now remember, this bond, the electrons in this bond, I count for both sulfur and for carbon. So I'm going to count this for carbon too. So this one has 2, 4. So this one is not satisfied. It only has 4. So I need to find a way to take away from to like give some to carbon without taking them away from sulfur, because sulfur is satisfied. So the way I do that is by turning a lone pair into a chemical bond. All right. So I'm going to take any of these lone pairs around this sulfur and I'm going to turn it into a bond. All right. So I'm going to redraw this. And I'm going to do another bond there. So that's that lone pair. And then I'm going to put the remaining 2 back on there. And then I can see that now I have 2, 4, 6, so I need to do that again, except now I need to do it with this sulfur. So I'm going to take this lone pair here and put it there. All right. Now, that is one way to do that molecule. But there's other solutions for that that you might have thought of too. And so we'll discuss that in a little bit. But now I'm going to double check just to make sure that everything's satisfied with an octet. I've got 2, 4, 6, 8, 2, 4, 6, 8, and then 2, 4, 6, 8. So now we're good to go. So carbon disulfide, the way I've drawn it here, that carbon is connected to each sulfur with a double bond. All right, now the next problem is an ion, and I can see that because it is carrying a charge right here. And we need to remember what the sign of that charge and the number actually means. So if I have a positive charged substance, that means it's lost electrons. And in this case, because it's +1, that one is implied here, it's lost 1. And if I have negatively charged ion like nitrate or sulfate or carbonate, most everything is a negatively charged polyatomic. That means it's gained electrons. And the number of electrons it's gained or lost is the value of the charge. So here, like I said, I've lost 1 electron. Now, what does that mean for me in terms of how many electrons I need to place? Well, since I have a positive ion, that means that ammonium, that combination of elements bonded together, is missing 1 electron. It's donated that electron to something else, and that combination of atoms is missing an electron. So when I count up my valence electrons from the elements are here, I need to subtract one of them away, okay? So let's do that total here. So nitrogen is in group 5, so it has 5, and each hydrogen has 1, and there's 4 of them, so plus 1 times 4. So that's 9. So I've got 9 electrons, but then I need to take into account that charge, and that means I'm going to subtract 1 away. So I actually need to only place 8 electrons, okay? So now the next step is to draw the stick structure, and you can see that there's 1 nitrogen and 4 hydrogens. Hydrogen, because it can only bond and will only be satisfied only with 2, it will never have bonded to more than one thing. That means it's always on the periphery of a molecule, never in the center. That's always something to remember. Okay, so now I'm going to place 4 hydrogens around here, like that. And what I'm going to do next is place my electrons. And remember, I place my electrons simply by drawing a single covalent bond between the center and each surrounding atom. I have 8 to place. So I'm going to do 2, 4, 6, 8. All right, so I'm done. Like I've placed all my electrons. There's single bonded to each nitrogen and hydrogen is a single bond. But the last step here when I'm drawing an ion is that I need to account in the Lewis structure for that missing for the charge. And the way that I do that when I'm drawing the Lewis structure of an ion is to put the entire Lewis structure in brackets and then put the charge on the outside. That means that I have placed 8 electrons instead of 9, and that is a charged substance. So after I've done that brackets and put the charge on the outside, that is my Lewis structure, and I am all done. Right, so now you guys are going to work some practice on your own and check your work with the answer keys that are provided.